Rocio Delgado. I'm an engineer manager at the platform team at GitHub. I've been working here for about 16 months. I'm from Mexico. I live now in Brooklyn. GitHub is a remote company, so a lot of us work from home. I'm really interested in databases and data structures. Since I was in college, that is the class that I most look forward to attend. And to this day, I actually work a lot with databases and backend engineering. You can find me on Twitter with Roxy, and at GitHub, I'm Rocio. So databases have been around for a long time. In 1970, the ACM published this paper that's called A Relational Model of Data for Large Shared Data Banks. It was published by Edgar F. Code, an IBM researcher, and it's about, he proposed the use of relational data models where the schema of the data was not necessarily related or disconnected from physical storage. To this day, this is the principle of databases models, modern databases. And so this is just fascinating to me. And since then, in the market, we've seen very expensive databases, open source databases, NoSQL, new SQL, timeline, time series databases, graph databases, all sorts of. And data is always at the center of application development. But at GitHub, we've said YesSQL or YesSQL. And we use a lot of MySQL as our data storage. And well, I'm gonna show why and how it's that we do that. So the idea that NoSQL and SQL databases are in opposition from each other is not necessarily true. I don't agree with that. It's really not a system fits all. It's just whatever works for you, and whether you have the confidence enough on that technology and you decide to move forward with that. So at GitHub, we have the operational experience in the team to actually push boundaries a little bit and rely on MySQL as our backend. To give you an idea of the size of the database, there are some numbers, and you also can see the Octoverse that Chris announced earlier. But this is just a rough some numbers that are stored in our database. We have 16 million users, 125 million issues, 38 million repositories, and about 78 pull requests since 2010. These numbers are a little bit different from the GitHub Octoverse in the sense that they are reporting active, but this is like total. So this is like the size of our database and just like the main tables or data models. So you can see that this is actually generating a lot of information. There is like comments and other things that I'm not reporting here, but it's just to give you an idea of how large it is. Our team has also grown. When I joined GitHub about a year ago, we were 115 engineers rough. So now we double, and even we double the number of engineers or more, and actually double the size or more across the company. We are about 600 employees right now, I guess. So how do we make sure that we keep building features and we are keeping the site up and fast and it's reliable? So one concept that I'm really interested on is performance. I strongly believe that performance should be thought early on in the development process, just like choosing a data infrastructure or a JavaScript framework or a methodology. Performance cannot be an afterthought. And so this is like the concept of performance as a first-class citizen. And so if you have performance issues, it doesn't matter how great your product is, it's going to affect your morale, your customers, and your development cycle. But the real reason I'm interested in this topic is because in my years of experience, I've seen fires. And a lot of those could be prevented if you have a little bit of information up front. So we need to understand growth and build for the future. Prevent is also another important thing about infusing a culture of performance in any team. So what are the concepts or the aspects that you need to consider to build a culture of performance in any team organization? The first one is that it's everybody's responsibility. There is not only one team or person in your company that has to be the person to go to talk about performance. It has to be infused through management all the way from engineers, QA, even designers. When you're thinking on a feature, it has to be thought as a first-class citizen. So the second one is process and tooling, and this is what I'm going to spend more time talking about. It relates to automation, having infrastructure, and the tooling to support that, continuous performance, monitoring of production and other environments. And at GitHub, we rely a lot of robots, but not this one. This one. You may know Hubert already. He's our GitHub chatbot, and he's customizable. It's built in Node.js and CoffeeScript. It's open source, and we use Hubert for pretty much everything in our company. A couple of examples. So we use Hubert in Slack, and we run every graph that is available to share when you're building a feature, for instance, or if you're talking about a certain system, or just looking at, in this case, we're looking at per browser page load time. But pretty much every graph that's available in Graphite, we can dump it into Slack. And it's really good for onboarding people into teams. And at the company, also it's good for sharing knowledge or information. Since, as I mentioned, we are a remote company, then it just makes it very easily to have the data available in Slack. So relating to the database, we have about 65 different MySQL commands that run in Hubert. From, I don't know, setting up a new server, actually deleting, dropping tables, I don't know. So this one is one of my favorites. It's called MySQL table sizes. So if I'm an engineer working in a feature and I need to decide whether I'm going to be adding a new column or, I don't know, just want to know more about what the system is. This is something that is not typical for an engineer to be doing, and you don't need to ask the database infrastructure team to just go and see it yourself. You can make a decision based on that, or just have the information on the back of your head to make the decision about what you're building. We also deploy code via Hubert, and we deploy code through every environment. And well, we have staging, branch lab, which is, you can put a branch in a particular node, and you're just going to see your branch and test it. And everything happens through Hubert. So not only our team grew, we also grew our systems and infrastructure, and with that, the need to support it. At some point in the past, engineers building a feature will do everything from product design, the development of the feature, setting up new servers if it was needed, and running database migrations. And this was all thanks to Hubert. However, sometimes, we start growing, and we also have a lot of databases now in different clusters. So running migrations start getting a little bit complicated, and sometimes people will need to babysit the migration. We use different processes in the past. And so it was not necessarily scalable as a team, and it was not scalable because, it was not a job well suited for an engineer doing application development. What happens if the database goes down, right? Like, that would be pretty bad. So fortunately, we also have, we also grew the database infrastructure team grew, and we have a team of awesome engineers looking after the database infrastructure, which are the second row right here. Yay! Shout out to the partial. So fortunately, they came to the company and said, we need to change the way we do things. And they developed this new online schema migration tool for MySQL called GitHub's Online Schema Thingy. That's the official name, or Ghost. And so they took over the operation management of running migrations, and that was awesome. So Ghost is provide possibility and many operational perks. And so with Ghost, we really find a top-notch solution to our database migrations problem. However, the process of running a migration is still a little bit tied to development practices. So a developer needed to open a PR, or still needs to open a PR with the migration. And if we use Ruby, so it's like after record migration, you need to generate the SQL that's going to be executed. So you had to have a local development environment. So that was not something database infrastructure team needed to do for the daily work. So we went back to square one, right? In the sense that we have people doing something that is not necessarily the first thing that they should be doing. So we need to take a step back and develop a process to go around this. And we came back with this migration queue process, which also runs in Hubert. And the name is not necessarily important, but what we can do with migration queue is a developer opens a pull request. It then is reviewed by somebody in the platform team. It gets added to a queue, then it gets a schedule. We have commands to show, actually, okay, yeah, we can add, once a migration pull request is reviewed, it gets added to a queue, then we can see how many are pending review or how many are waiting to be scheduled. Once I get a schedule, we actually have the command generated to run the ghost migration directly into the pull request. So there is no middleman. So the middleman is actually Hubert and Ghost, right? So this is how Hubert adds the ghost command into the pull request. So whoever is going to run this migration just takes the command and runs it. And if you want to know more about Ghost specifically, there is a talk that Shlomi is going to give at 1, I don't know the schedule of that. I think we're 20 minutes behind the schedule. So it's like 1. The next one after lunch. So go and see that one. It's really interesting. So this is how we generate the ghost command. So there is no development environment in between. And so we can also see if the migration is running and how much it's going to take, and everything is in Hubert. So perfect. We found our process. We have database engineers doing what they do best. We have application engineers, what we know best. And Hubert and Ghost do the work. So process alone will not solve all the problems. Without the right tooling, understanding, and empathy between teams, it cannot just work, right? We need to put in the shoes of each other and see what is that we're missing here. And the process has to be efficient enough to accommodate for the needs. A process should provide clear communication, and all the steps should be very well communicated across every party involved. It has to foster collaboration, and it should be meant to remove friction between teams and not to add more process or bureaucracy. And a process should be paired with the best tooling for the job. So in this case, Ghost is the tool that we use, and Hubert is the tool we use. We use MySQL as a database. So it's really not about which tool you use. It's choose the right one. If it's a shell script, that's fine, right? We choose whatever it will work for you. And make it clear what you are optimizing for. In this case, Ghost optimizes for scalability. So speaking of tools, what else do we do to be on top of performance problems when it comes to our database? We use Peak. This is an open source tool that was developed in GitHub, but is now it's moved out of GitHub, its own branch. And so what Peak does, it puts a little bit a bar on top of your application. And as you can see, right now we're reporting SQL, timing, Elasticsearch, cache, but you can really put anything you want. In this particular example, if I mouse over the SQL section, I can see all the active record objects that are being loaded in this page. So if I'm developing a particular feature, I can see what's being executed. And I can also see the actual query. So this is a very good way of finding N+1s or any performance problems when you're developing. Another tool that we use is Haystack. Haystack is the internal exception tracking tool. But we use really for everything from exception monitoring to like slow queries. And this is a little bit different from reporting slow queries from a database perspective, because you can customize what does a slow query means for your application, and it doesn't need to have anything to do with the database itself. So the third and last component of a performance culture is metrics. And I've shown a couple of examples, but really what it is about is to take a data-driven approach and incorporate metrics as part of your development cycle. Individual metrics are important, not necessarily just like first time to first byte or full request page time. It has to be more about individual aspects, so you can easily identify which aspects of your applications are the ones causing problems, like if it's I/O, memory, reads versus writes in the database. It's really important that you do granular metrics. A couple of examples of this. We have SQL tables total time. This particular graph is showing the top 12 tables that are most written to. So this is a good example of identifying which aspects of the application could be improved. Perhaps we have a table that's being written a lot and we need to do batches or a better way of writing to. The second example is the common needles in Haystack. So after a deploy, when we are checking if we did some regressions, we can see the individual rates of issues like slow queries or JavaScript exceptions, slow pull requests, and well, that is up to you. But this is really helpful after a deployment, so we can identify if we had we introduced new issues. So the key point about having measures for everything is to remove noise and just look at what is important to you. Although it's really important that you do individual metrics, as I mentioned. I came across this latency tip of the day, and it's measure what you need to monitor. Don't just monitor what you happen to be able to easily measure. So you can measure everything, but really it's not going to be useful for you, then don't do it, right? So how does it look when we put it all together? So I was deploying, and I was looking at Haystack, found this slow query. The slow query actually shows the SQL that is being executed. I opened an issue just to report it back, but I took a stab on it and used another tool that is called Vivid Cortex. This is a third-party tool. It's not us. So I went and found the similar queries, and I saw that, yeah, in fact, it's been spiky for a couple weeks. So one other thing that we have available for us via Hubert is the ability to copy tables from production into a staging environment. So it's really hard to test with data that's the size that I mentioned in a local environment, right? So you cannot replicate that, or perhaps you can, but you will not have the capacity in your local server, even if you can generate that data. So cloning a table into a staging environment, that's something that we have available that is really, really useful we can do it ourselves. So Hubert, we run this command, Hubert copies the table and notifies when it's ready. It could take some time, it depends what the size of the table is. So I tested my new index, I figured it was a new index, which I'm gonna talk a little more about that later. And so realize that, yeah, indeed, the new index makes the query executes in 300% more efficiently. So open my pull requests, provide a little bit of context, pointed to Haystack, Vivid Cortex, all the tooling that we had. So it's instead of like me explaining what happened, you can see it yourself. The migration is approved. Somebody approves and then adds the migration to the queue. So Hubert comments that it's ready to be scheduled, and it actually mentions the teams that are needed to be mentioned. So then the migration is scheduled for today immediately, and Ghost runs the migration, or somebody runs the migration via Ghost through Hubert, and it's done. It's ready to to verify. So I ship my PR, and I just want to make sure that everything is fine. So I can run the explain command or the execution plan right there in Hubert, and I can see that my new index is actually being used. And well, so far that's a good. We profit. I go back to Hubert, run the graph that I was looking at before, and this is how it looked like after the index. So everything I did, it was no interaction with a human so far. Then I go back to BB Cortex, and I also see the graph really looks like it's an improvement. Also haystack, no more needles. So if this is not available to you, if it's not possible to copy a table to a different environment because maybe it's expensive or it's really the tooling is not there yet, you can use science. And what I mean by this is you can actually add the index into your database and test it with Scientist, which is a library that is a Ruby library that's for code refactor. But we can use it sometimes for performance monitoring, not just necessarily if like a code refactor in terms of performance, not necessarily changing entirely the code. So in this case, I'm using Scientist to test a new index, and I basically have the two. I'm giving it a hint, so the old index versus the new one in an experiment, and Scientist has the graphs that each of these lines, the performance that they provide, and it's all built in. So I can just go and look at this graph. My candidate is a new index, which is in green, and the control is blue. And I can see that this index is slightly better than the old one. So I can ship my PR, remove the experiment. And this is as I said, is open source, so you can use it in your projects. So to summarize, the performance culture will not only improve how you think about a feature, it will definitely improve the way you write code, because you will have this mindset of like, hopefully you will think about it before building something, so it could be scalable, and it's going to be double awesome if you think about it in terms of performance. And so I'm talking a little bit of databases here, and I want to mention MySQL, right? Why would you use MySQL as our primary data store? For us, it's all about predictability and high availability, obviously performance, but it's also about the knowledge that we have in the team. So it gives us a lot of confidence to have the operational experience to being able to manage. And most importantly, we package it up and ship it in GitHub Enterprise, which has to be very reliable. We're not there to do the same experiments we do in GitHub.com. We have to trust it as a solution. So really, those are the main keys. It's not about selling MySQL as a solution for you. It's all about we chose this and we decided to push a little bit the boundaries. Most of our data models are structured data. However, we also went a little bit beyond, we went a little bit beyond what a typical usage of MySQL looks like, and we started using key value data in MySQL. So this is how the table looks like. This is another MySQL command in Hubert that gives us the table definition, so I don't have to ask anybody, and it also can give me the size and which indexes are available, etc. So this is the key values table. It's very simple. We only have a key and values column, a couple of timestamps, and the index on expiration expires at to be able to prune. So you can set up a TTL as well, and we'll have a process that's going to clean up that data whenever the time is, whenever it has. Also, there is an interface in the code that will not return results, obviously, if it's past the TTL. So it's very simple, and we use it. We have a couple of usages, but one of the most simple ones is the dismissal of notices. So across the application, we have a couple of notices that whenever we want to show or call to action to our users, like if this is new, look at new feature, or report a message to every user. But we also need to make sure that we don't display it multiple times. So this is not really something that belongs necessarily to a common table. Like that, it seems, it's not. I could have a notices table, but a simpler approach could be just in a key value format. I could have key, it's my user and the notice that I'm displaying, and the value, whether the user dismiss it or not, it could be the presence of the key in the key value store. So this is something you could implement in Redis or any other key value store. However, we took a stab at MySQL. So basically, when we show some of these messages and you click the cross to dismiss it, we store it as a key in MySQL, and like something like this. So we store user dismiss notice, the notice itself, and the user ID. The notice could be there or not, we actually just check for presence and whenever we're going to display the notice. So really, we use KB for things that are going to be read intensive. We're really good at scaling reads in our clusters. So KB is in MySQL, we try to implement some of the features that are like read intensive, but not necessarily super heavy writes. And so far, it's been proven to. So this is a little bit of how we use it. So right now, that we don't have a lot of features yet on KB in MySQL, but we have about, if you can see, we have a lot more reads. The blue line is reads or the selects over this table. And we really have a very small number of inserts and deletes. We can even see them here. So that's a really, it's really about the volume of reads versus write. And so far, it's been proven to be helpful. So speaking about indexes and MySQL and databases, what is a good indexes strategy? This is something I'm really keen on. And it really, sometimes it's not about the tooling, it's how you use the tool itself. So if you understand really well how, in this case, MySQL works in terms of the storage engine and how indexes are stored behind the scenes, it will really help you a lot to improve performance. So one of the things that we tend to do is just focus on the most important queries, like the ones that are run the most, or the ones that are like, the slowest ones, obviously. But in terms of volume, look at the heaviest queries first and try to optimize for them. If we take a stab at all of them at the same time, it may not be a good strategy because, as I'm going to explain, having too many indexes actually hurts performance. So building an index order that benefits more queries. So if you look at when you're analyzing queries in your database, taking some of the similar queries and try to optimize for a couple of them as opposed to individually, that will help you also reduce the number of indexes on a table. So for instance, I have a query that is select star from issues, where user ID equals 2 and repository equals 2. So I'm using equality in both columns. But I have another one that is looking for a repository, but a user greater than. So the inequality condition in this one is going to be important. And so the index that benefit the most for those two queries, it's going to be repository ID and user ID with repository ID first because of the equality condition. And then we're still going to be use the same index for both queries, but if I do the opposite, it will only benefit one. With that said, prefer to extend existing indexes other than adding ones. As I said, it's really bad. At least for MySQL, I know maybe Postgres have like the ability to add like index merge, but it still is going to hurt performance if you have too many indexes. And so really being keen on that, it's really important. And favor multi-column indexes. A lot of us tend to add an index on every column just because it seems like it's going to be useful, but really it's better if we have a multi-column index than one in each column. So what is not a good strategy? Obviously, the opposite of what I said. But so again, another graph one like there is a lack of index. Can you guess when we added a new one? Indexes. The reason why indexes are or hurt performance on writes is because they do require space. And obviously, the more you have, the bigger the table. And the other thing is when you are going to write to the database, you also need to write to the index. So it's going to affect the performance in writing. And actually, even in reading, it's going to affect because the query analyzer is going to look at all the possibilities. And the more you have, obviously, it's going to take a little bit longer. Another command that we use for MySQL, this is one of my favorites, is dead indexes. And so this, every time we're changing something in one of the tables, you have the ability to look for redundant or non-unique unused indexes, so you can make it, leave the can better than you found it. So if you're going to add something, maybe you can remove something as well. So this is another of those 65 commands that we have. Supports with emoji. And so I titled this talk YesSQL, right? And it was not about to selling you anything, just to show how we use it. But really, I really want to talk a little bit of what's coming next in MySQL, what we are playing with. 5.7 has JSON data type. We also have in 5.8 common table expressions and the invisible index, which is the ability to add an index, but given a hint to, not a hint, but actually tell the optimizer to not use that index, and is really good for refactoring. Or, I mean, I haven't actually used it, but that's what it will be good for. And this, also, it's really good. So it's really a work in progress. Choosing the right tool for the job, it's hard. But I encourage you to take a data-driven approach to making decisions. So what are we doing next in terms of databases and data stores, and to try to improve the way we build software is have better dashboards. For instance, we can do the same things we have for the database for Elasticsearch or for Redis or for every other data store that we have available. Also, while migrating over to Datadog, this is a work in progress. I don't have any dashboards so far, but it's looking great. And it also has integration with Hubert. We have also one thing that we want to improve is the discoverability of Hubert commands. As I said, a process should be able to easily communicate the steps. So sometimes it's hard to find everything that's available because we have so many. And so I really encourage you to talk to your team about this, to encourage to take a stab at performance beforehand when you're developing a feature, and not leaving it to the end. So one of my favorite quotes is to slow down to speed up. So that's really a motto that I want to take on. So these are all the links that I use. I'm going to have my slides available in Speaker Deck later after this talk. And so thank you so much for listening.